Hello everyone. Today I will explain my homework for Part 1, exercise 4.2. Write a three language to control piston with set and reset function and show frequency together. Next, I will explain the process and the key knowledge points clearly according to the PPT. This homework has four main goals. First, master the logical and the usage of three core PLC programming language: lambda diagram, function block diagram, and structure text. Second, understand how set and reset functions work and use them to control the piston. Third, connect the PLC program with fluency simulation to test the mechatronic control logic. Fourth, compare the features of the three languages and learn which one to choose in different situations. Before starting the explanation, let's review three key knowledge points. First, set and reset functions. Set makes the output signal stay on after meeting the condition, even if the trigger disappears. Reset makes the output signal stay off after meeting the condition, and the reset usually has higher priority. This page tells me about the three PLC programming languages. First, lambda diagram (LD) is a picture style like drawing relay circuits. It's good for electric engineers. Second, function block diagram (FBD). It's using small models to build logical. It's easy to see and works well. Third, structure text. It's like high-level language. It's good for complex logical and calculations. This is IRO or allocations table for the homework, which clarifies the PLC address and function of each input and output signal. Input signal include start signal to limit switches S0 and S1, and reset signal. S0 detect when the piston is fully retracted. S1 detected when it's fully extended, and the reset is for emergency stop or restoring the initial state. Output signal are two solid variables Y1 and Y2. Y1 controls piston extension, Y2 controls piston retraction. All single address and standardized to ensure consist in programming and simulation. First, the lambda diagram. The programming logic is clear. In the first round, when the start signal and the target position signal S0 are targeted together, set Y1 and set Y2 to make the piston extend. In the second round, when the extended position signal S1 is targeted, reset Y1 and set Y2 to make the piston retract. In the third round, whenever the reset signal is targeted, reset both Y1 and Y2 to stop the piston. Later diagram use several connects to show trigger conditions and set or reset commands to keep output status. It very interactive, just like real circuits. Next, the function block diagram (FBD). FBD builds logical in a model way. I use and blocks to combine trigger conditions, start and as the result go through an AND block. Then connect to set Y1 and reset Y2. As one goes through an AND block, the connects to reset Y1 and set Y2. The reset single directly connects to two reset blocks to reset both Y1 and Y2. This way connects blocks through single flow with a clear structure and easy return. Perfect for showing the relationship between logicals. Finally, the structure text ST. ST use similar to C language. First, define our variable and their PLC address. Then use if conditional statements to realize logical. When start and as the result are both true, set Y1 to true, piston extends and Y2 to false. When S1 is true, set Y1 to false and Y2 to true. Piston retracts. When reset is true, set both Y1 and Y2 to false to restore the interior state. This way has simple and readable code, good for handling complex condition combinations. This page introduces the fluency simulation design and its connection with PLC. First, build the circuit. Crew commands include a oil tank, pump, relief valve, two piston, four-way slaughter directional wave, double acting piston, cylinder and limit sensors. The solid directional valve is controlled by Y1 and Y2 of PLC, and the limit sensor signals are used as S0 and S1 inputs of PLC. The piston extends after starting, retracts automatically when touching S1, and stops immediately when reset is triggered. Let's look. Finally, let's summarize the guide from this homework. First, technologically, I mastered the programming logic of 3 PLC language and deeply understood the core feature of maintain state for set or reset commands. Second, practically, I completed the whole process from hardware I or O mapping, program writing to flow sim, simulation connection, and verified the control logic. Third, through compares, I found that ladder diagram is good for simple logic. Function block diagram for model research and structured text for complex conditions. We need to choose flexibly according to sensors. First, the key point is defining trigger conditions and single prostate for set or reset logic. During simulation, I or O mapping must be occur, otherwise the effect will be affected. Let's look at This is all my homework presentation. Thanks for your listening. Goodbye.